Thank you all for coming. Thank you very much. First, I want to say thank you very quickly to Delivery Hero for providing this amazing space. Also to Amanda that is sitting here. If everything's working well, it's thanks to her. So a lot of thanks to her directly. She did a fantastic job for the event with helping with the food and everything. So yes, thank you all for coming to this second edition of the Unstructured Data Meetup in Berlin. I'm Stefan Batifol. I'm going to be your host today, speaker, organizer, cleaner. If you have any questions, come to me directly. I will not introduce myself because it's a bit awkward, but yes, that's it. I'm just going to go very quickly. I'm a developer advocate at Zilliz. For the people that don't know developer advocate, we usually write a lot of code, then we get to talk about it. That's our job. If you have any questions, you can find me directly on LinkedIn. You can send me an email. You can find me on Twitter. And yes, today I'm here to talk to you about multimodal embeddings in general. So you'll see what does multimodal mean, how you can use embeddings for multimodal. So let's go. I also have a demo, which is something I shouldn't do, but I like to do demos online. So yes, for the people that don't know what we're doing, so I work for Zilliz. We are the creator and maintainer of Milvus, which is an open source vector database. You can check it out. We are built for scale. That's our motto, basically. We go from 1 to like billion plus vector scale. Then we have a lot of different open source products, GPT Cache, which is another famous one. We have Nowhere, which is a vector search engine. And then, we also have to make money. So open source is cool, but we also have Zilliz Cloud, which is our offering. And then that's basically Milvus hosted with a bit better performances. So yes, if you have any questions with regards to Milvus, come to me. I'm not paid to work on Zilliz Cloud or anything, so I only work for open source. So if you have any questions with regards to that, feel free to come to me directly. We have some customers, that's what I was saying, when we work for scale. We were created a long time ago now. We're created in 2017, and our customers are usually bigger customers. So it doesn't mean we don't work with like smaller customers. It just means we can work from small and big customers. We partner with like a lot of industry leaders. You can see all of them, like all the cloud providers, basically, all the major ones, data platforms, Gen AI tooling, and we also partner directly with chips manufacturers. So we partner directly with NVIDIA and Intel, so we optimize directly on their chips. So if you ever need GPU vector search, feel free to check it out. Same for Intel. We have some really cool partnerships, so then it's even more performant. That is it for the sales part, and now I can talk about the tech. So yes, where do vectors come from? I'm going to give you a quick intro to, maybe for the people that are not familiar with that, what are the embeddings, where do we get them, and things like that. Then I'm going to talk about OpenAI Clip. Then I'm going to explain quickly what is multimodal and what we mean with that. And then I have a demo. Let's hope my demo works, though. So yes, where do vectors come from? It's basically, you have your knowledge base, which are some different documents. So you can think of like images, you can think of audio, you can think of videos, you can think of text. You have your documents, you put them through a deep learning model, and then usually if you put them through a deep learning model, you're going to make a prediction. What's happening here is that you're going to cut off the last layer because you don't care about the prediction. And those are basically your embeddings, and those are your vectors. And something that is very important, though, is that when you put them through a deep learning model, you have to use a deep learning model that understands your data. So you're working with images, you have to use a deep learning model that's been trained on images. You're working with text, you have to work on you have to use a deep learning model that has been used with text. You want to detect pictures of dogs, you have to work, with like a model that has been trained on detecting pictures of dogs. That's how it works. So then, yeah, you have your vectors, and then you put them in a vector database, and then you do similarity search. And that's basically what we do all the time. And it's pretty nice. It works very well. Usually, then you have like different embedding models. That's usually how you go from your data to then vectors. You put them through an embedding model. And what's very important is that, again, you have to use embedding models that have been trained for your data. So if I work with German documents, it's usually better to work with an embedding model that has been trained on German data, that understands the language. You can also obviously go from German, translate it to English, then use an English language model, embedding model, sorry, but it might not work as well. You have a lot of different models, so it's really cool usually to check them out, try them out, go on Hugging Face maybe, check the leaderboard, check, like, okay, I need German model, so then I'm gonna look at the leaderboard for this one. I need images, so then I'm gonna look for those. You have a lot of those available. Have them, check them out. Like Gina, for example, is the one I always quote when I use German data. As from what I've seen, it's the best one that works for German data. So if you need to use German data, maybe check them out. So yeah, those are your embedding models. And what happens is that basically it's like you have a text, which is like a building with a small window, put it through an embedding model, it generates a vector. And that's all about the embeddings. And then everything is stored in a vector space, as we call. And then, like this is a very simple one. Like obviously it doesn't look like that. This is 2D, and you have some text, which is a building with a small window, which is like on the top left. Then you have Helsinki, the capital of Finland, on the right. And they're not exactly close to each other. But then you have a text with a dog with a smile, and a golden retriever is a breed of dog. Those you could say are fairly similar. So then in the vector space, they're going to be close together. And that's how it works. What if you add a new text? The iPhone is a line of smartphones produced by Apple, then again, embedding model. And then you will see like it's going to find its way in the vector space. It's not going to be close to the dogs. It's not going to be close to Helsinki. It's just going to be on its own. And then if you have, I don't know, other products by Apple, like the iPad or something, they would very likely be in the same vector space and be nearby. But then what's cool is that, at least with vector database in general, is that you don't work only with text. You can work with like a lot of different data. You can work with images, audio, videos. As long as you have an embedding model and you can transform it, then we can make it work. So that's what I did basically, and then you'll see directly during the demo later. But then for this one, I'm using OpenAI Clip, which I won't go into the details because not the goal of this talk, but basically it takes text, put it through a text encoder, and then produces some vectors. And then it's the same for images. It's going to put it through an image encoder, and then you're going to have vectors. And those are the image embeddings. And then we have the text embeddings. And then Clip is just trying to learn the pairs. And then that's how you can then write a text, and then it will be able to find something on the image, that relates to it. And that's what Clip is doing. It's actually really cool. And then how it worked and how it learned something is that you obviously have some examples that are positive, so that are like really related to each other. Like the first one, which is two dogs running across a frosty field. That you can see the image is actually two dogs running across a frosty field. Then you have other images which are not related to two dogs. And basically Clip will learn that, okay, the two dogs and those two images are actually the same. So they should be in the same vector space. But then the image of the whale is not two dogs, it's not related to it. So then basically you should minimize your score for that, and then you learn that those images are not related, so you don't care about them. And if I type that, you don't return me two dogs. That's basically how it works. That's Clip, and it's actually very cool. And then what is multimodal? Well, it's basically that, what I said before. So if you have a picture of a dog that is very happy, as you can see here, you put it through an image encoder, and then you get vectors. You have a text, which is a dog smiling. You put it through a text encoder, and then again, you get vectors. And they will be related. They should be very close in space together because they are, it's actually, well, a dog cannot smile, but you can see on the picture that maybe it's a dog smiling. So then they would be very close. And then the third one is audio, so just sound. And you can imagine like a golden retriever making sound. And so then you transform all of those, and then they happen to be then in the same vector space. And yeah, then you remember before, when I was like, 2D with my different embeddings. So then here is the same for multimodal. They're just going to be projected in the vector space. And you have one which is a building with a small window, which is text. Then you have someone that is surfing that looks like beginner surfer, like you've been surfing for like 4 or 5 days. Usually you look like that. So then that's an image, and then it's in a specific vector space. And then you can see then, a dog with a smile, which is a text, and then the picture of a dog smiling. Then you can see they are both very close to each other in the vector space. And that's what happens when you have multimodal embeddings, is that the image or an audio or something, they will be very close together. And what's cool is that, I said it before, but you can search over everything. So you can search over images, audio, text, and everything you can transform, then you store it, and then you can also return everything. And that's the best part, is that you don't have to return the same thing that you search. If you search for text, you don't have to return text. You can return an image, or you can return audio. And that's the beauty of multimodal embeddings. And yeah, that's then what I'm going to try to demo you now. And I'm going to pray to the demo god that it's actually going to work. Also, I'm actually going to sit here, so then I'm comfy. So I'm going to show you, I'm going to not talk about anything about the pip install, because those are very boring. I'm going to go full screen, and I'm going to zoom way more than that. All right. So we install everything. We're happy. Like Llama Index, I'm using Llama Index for this demo. Allows me to, transform some data, to load some data. Then I'm using Milvus to store our vectors. And then I'm using Clip from OpenAI, which is open source and is available directly on their GitHub. So yes, I'm just going to show you this demo is I'm getting directly titles from Wikipedia. So I'm getting articles from Wikipedia. So then I'm getting the text from the Wikipedia articles. And then I'm also going to get all the images from the Wikipedia articles. I won't go into over the details over all the code, because it's a bit boring. But yeah, basically that's the action, is like you go through Wikipedia, you check, you get all the data. I'm downloading everything. Then I'm installing everything, and then that's it here. Like I have my Milvus client, which I have locally directly. Then I'm just going to load all the text I have that is coming directly from Wikipedia. I'm going to use GPT 3.5 Turbo for this demo. And then I'm using a BG embedding model. So then you can use obviously different embedding models. I feel like BG was pretty good. It's in English. It's a generic embedding model, so it's usually quite good for those things. I'm creating then my collection with everything, with a dimension that is required by the embedding model. I store everything, and we're happy. And then I'm just going to say, hey, please, this Milvus, please, we're going to use this as a query engine. So that means that then I can query it directly. Here, you can see that I'm loading Clip. So that's directly from OpenAI. I'm using a very specific model they have. You can check out, they have a lot of different models, but this one is the one that can also use images. And yeah, maybe I should run things so you can actually see it, but you can see it's pretty big model, but now in comparison to, I don't know, GPT-4, what's rumored, those are small models. They don't have that many parameters in comparison to what we had, to what we have now. And it's the same, as I did before for the articles for the text. Now I'm doing the same for the images. So I'm just downloading all the images we have from this Wikipedia article. And then I'm going to assign a UUID for each image. So then, I can know which article is related to which image. It just makes my life way easier. And yeah, those are the details. I'm just getting images in a specific format. I'm trying to not DDoS Wikipedia so they don't ban me. And then I can show you, I can plot the images that I have. If it works, please work. But you'll see all the images. And if you've ever been to Helsinki, or if you've ever had an iPhone, then you should recognize the images. You have to use your imagination, because even I can't really see. But imagine in the back here, if you see, here is an iPhone. Here is an iPhone. At the bottom, it's a Tesla. Helsinki, you see it in the middle. And so those are the images that I downloaded. Then again, I'm going to, now that's the magic part. That's where I create all my embeddings for my text and my images. So I'm just going to run it because otherwise it's not fun. And then that's also here, you can see all the different models available on the Clip. So depending on your needs, you might not need to use the one I'm using, which is VITB32. Yeah, here I'm loading all my documents. I'm actually loading everything into Milvus directly, and I'm not lying to you because I have overrides equal true, which means if the demo fails here, my whole demo fails. So let's wait, and it worked. And here I'm just saying, please take a text query as input and return the most similar image, which is what I was saying before. Just because you give a text as an input doesn't mean you have to have a text as output as well. So for this one, for this demo, I'm just gonna, query a text using a text as a query. And then I'm only returning one image, which is similar, which should be in the same vector spaces as what I said before. So here you're just plotting things. I'm defining my function, and then I have a query, which is the first one, which should work, which is, can you tell me more about the iPhone? So that's the query, that's text. It's gonna then, get the data that I have from Wikipedia directly. So the iPhone is a line of smartphone produced by Apple, blah, 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 blah. But then it's gonna return the image which I used in Wikipedia, which I got from Wikipedia directly. And that's basically multimodal RAG, as we would call it. And that's something that's something that can be very useful for you, depending on what you're doing for work. But you can have text data and then images, and then you can have you can just give text and have images as a return. I lived in Helsinki in the past. So what are the popular tourist attractions in Helsinki? So then it's going to tell you some data, and here's the cathedral, which is like the main cathedral of Helsinki. And that's basically it for multimodal RAG. So you can see, again, just because you have text as an input doesn't mean you have to have text as an output. And it can be usually very useful, and that's just the similarity score you see here. And that's kind of it, I think. Yes. Questions? Yeah, fuck it. Yes, I'm going to come with a microphone directly.
How do you ensure that the different vectors are close to each other? Like, do you train the networks together? Is it one network for text and a network model for text and images and all of that? Or
so that's the power of Clip, basically. It's been trained on those to recognize those and to be like, okay, if I have this image and then this text, they train in pair, and then that's how they know oh yeah, those are two dogs. And then you have a text of it actually on the training set being like two dogs running across a field. And then you have the opposite as well. Like you'll have this image and then a whale getting out of the ocean. And then those, they know they are not similar. So then they also know to not associate those. And then I'm using that. And a question over here. Okay, perfect. Any other questions otherwise? No? All right. Thank you very much. Yeah, you can chat with me on Discord. Give us a star, add me on LinkedIn if you have any questions. But yeah, thank you very much. I'm going to call the other speakers now because I'm the host and speaker, so it's a bit awkward. But I'm going to call the other speakers here on stage. And I have to look for your bio because I have a very bad memory. But yes, the other one is multilingual narrative tracking in the news and real-time experiments. I'm here with Robert, which is the founder of Emergent Methods, where he leads the software development and research projects. He also draws on over a decade of experience building a variety of open source software for distributed training on supercomputers, cluster computer orchestration, and modeling physical systems. His company is actively building high-throughput LLM enrichment for real-time news indexing at production scale. Welcome. And you can use this one.
Perfect.
Thank you.
Thanks. I appreciate the introduction, and thanks to Delivery Hero for hosting this. And I'm really excited to talk to you. I guess it's going automatic. Hold on. Just make sure. Okay. I'm super excited to talk to you about how we're playing with the news with all these fun tools that are available to us, open source, and it's just a really great time to be a developer. And at Emergent Methods, we're just having fun. And I do want to mention that I'm here communicating it to you, but this is a team effort, and Ellen is in the crowd here. This is mostly her work that I'm presenting to you. There's a lot of engineering behind it, but the fun, smart stuff is certainly coming from her. What do we do at Emergent Methods? We are full open source software. Everything we build is open source. We're just committed. We benefit from the open source community, and at the same time, we're trying to give back. We built FloatApt, which is our high throughput adaptive modeling cluster orchestrator. And the whole goal of FloatApt is to let you orchestrate services, but also do a little heavy lifting here and there when you need to load in a Hugging Face model or you need to train a quick classifier. The goal is to let you orchestrate that on a cluster. That's FloatApt, and FloatApt underpins this entire presentation. We've built a few other softwares here. I'm not going to go through them. Ask News is the product that we're working on. So what's the point of engineering news context? Why do we need to do that? There's a few reasons. This is a really important point. This is very topical. We should really enforce journalistic standards. It's very dangerous for an LLM to be making claims without supporting evidence. Even just from a product perspective, you probably want your LLM to know about what's going on in the news right now, if it should be aware of that, right? It could be as simple as creating a friend that chats with you, or creating something more powerful like a financial analyst's assistant, right? These things need up-to-the-minute news. But if you're going to start diving into this world, it needs to be diversified across language, across country, demographic. This is a really important point, and that's what we're going to dive into in this presentation. You want to avoid stale and outdated reporting, minimize hallucinations, and if we're going to put all of our effort into it, we want to scale it to you guys so you can just use it quickly. So let's talk about engineering the parameter space. And I'm going to try to move quickly to get to the end of the talk. And I'm really happy that Stefan actually introduced embedding to you, because that means I don't have to go too deep into it. But let's just define the objective here. Let's step back. For us, our objective is a clean parameter space that allows us to cluster on news topics across diverse perspectives. We want to be able to represent entities, especially those originating from small demographics. And we want to normalize across language differences, because if we are going to start comparing how Egypt is reporting versus how Germany is reporting, we need to normalize across that language barrier. So let's prepare that embedding together. I'm going to step through the new method that we're taking for the enrichment of an article is take the title and full content and use an LLM to custom extract and enrich, okay? That includes translation and summarization. Traditionally, you might use a summarizer, but those are inadequate, because summarization now in this domain, we need to ensure the summarization includes evidence to support claims and attributions. Otherwise, it's not going to bubble its way up to your final LLM output, right? It's so important to properly extract entities that we're investing research into fine-tuning the state-of-the-art Gleiner model for news. And that'll be open source shortly. We're working on it. Look out for that on Hugging Face, and that's great work by Ellen. I do want to mention that if you use an LLM for one component of your workflow, it provides flexibility, adaptability, and that leads to product opportunities. So consider replacing an old module with an LLM for this purpose. Of course, building the embedded page, he just discussed a little bit about how you create the vector, but when you decide in our domain, the document that gets embedded, that is determining a lot of what happens above, right? This is foundational to the entire system. This is going to control your retrieval speed, your retrieval quality, storage costs, cluster and compute. We're doing a lot of clustering. We'll talk about that in a second. Of course, you want a good vector DB. This is the beating heart. You want it to be parallelizable. You want all sorts of metadata filtering flexibility, because you have no idea what you're going to need to filter on. So let's talk about how we're tracking narratives in our parameter space. We've just built it, but first I do want to define a news narrative. It's a series of related reports which occur through time. There should be multiple points of view, of course, and there are definitely going to be errors, accidental and purposeful. That is a news narrative. So how do we do it? How do we track a news narrative? Well, we've got our parameter space and we spent all of our effort engineering the cleanest parameter space we could. So now we can cluster it. And these are clusters of semantic similarity, which we can see, okay, in this topic B, we've got multiple countries represented, multiple languages, multiple sources. Most importantly, competing perspectives. If you're going to be reporting on a narrative, you need to know how Egypt is reporting and how Germany and the United States. But how do you connect it in time, right? Okay, we have a time window. We did our clustering, great. We got some topics. But how do we say, hey, this is an update to a story that occurred 4 days ago? That's an important point because we define the narrative as a sequence of events. Well, we cluster again, and you can connect these clusters with a variety of methods. I don't want to dive too deep. You can adaptively retrain a binary classifier per cluster. You could track the medoid centroid drift and use a hypersphere to try to define if you've escaped an old cluster or if you've re-entered a new cluster. Or you could use overlap clustering techniques. I'm happy to geek out about this over beers after if anyone here wants to chat more. I know I have a finite amount of time here. This enables long-range niche tracking, right? So on May 1st, we have some cluster about Madonna's upcoming amazing concert. And then on May 6th, we report on what happened at that concert, and that's connected. And that allows us to do cool things like track the coverage or track the sentiment through time. And ideally, we've got probably Spanish ones if it happened in South America, right? I'm not sure I want a German source telling me what happened at a Madonna concert in South America. Maybe, but it looks like we have one right there. Okay, so now we've figured out, okay, hey, this is how we can track through time. How do we polish it? How do we enforce that diversity? This is an important point. Let's go back to topic A here, and let's look at what's inside of this cluster. And unfortunately, we are missing the flags, but U is, I believe, yeah, Russia. A is Ukraine, and E is France, and S is the United States. Very intuitive. I'm glad that those flags came through. Anyways, you get the idea. We've got some United States, we've got some from Russia, a couple from Ukraine. Well, we can select one from each. And then when we do our prompt engineering and our context building, we can ensure that each perspective is represented. Fantastic. That lets us identify alignment, ask for contradictions. What is Egypt saying versus Germany, or Ukraine versus Russia, most importantly? Okay, let's actually apply. Let's look at the death of Alexei Navalny. This was an interesting narrative for us to look at because now we have all these fun tools and we can see, hey, what's going on? How are the different countries reporting it? How much of their source coverage is devoted to this story? Because we're tracking, we're parsing 1 million articles a day and lots of Russian, lots of French, lots of United States. We noticed, hey, why does Russia have such a small percentage of their coverage devoted to the death of Alexei Navalny? We don't really know. Let's check into it. Why has France got a higher proportion? I'm glad the flags showed up in this particular slide. So we can look through time, right? We're doing that. We're tracking through time. We're matching clusters, and we can see exactly where red is Russia, the coverage of Russia. Yellow is France, and green is the United States. But we see some obvious red holes, which is strange, but still, there's nothing here. We're just looking, right? We're just saying what's going on. Well, let's look at where did Russia report, where didn't Russia report. Non-reporting is an interesting thing to look at. There are some interesting things. This is all the stuff that Russia didn't report on, right? The global leaders are accusing Putin of responsibility for the death of Navalny, or global outcry and protests. Although I think finally they were forced to report a bit on one of these pieces. What did they report on? they have to report on some things, but there are obvious holes. Okay, but nothing's proven here. How are they? Let's look at some other topics. How are they covering the Russia-Ukraine war? There's a lot of coverage. There's a lot of red, very consistent. There are no holes. You can look statistically. We've got a notebook. You can check this data out if you want later. But statistically speaking, they're covering the Russian-Ukraine conflict more than the United States, which makes sense, and equivalently to France. But what about Trump's new shoes? I wonder how much they're covering that, right? Trump released some golden shoes to raise more money for his campaign. I'm sure you're aware. Interestingly, there's a lot of Russian coverage, or not a lot, but somehow equivalent coverage on Trump's new shoes to the death of Navalny. Equivalent amount of coverage. Interesting. Check out the Google collab if you're interested in more. Ellen wrote a sweet Medium post on it too. So I think I'm running out of time. I just want to say, hey, we've done all this work. We want to share it. Obviously, we've created a product. Ask News, we want to give you the context with just a query. So the goal is one line of code for you. You need to get some context somewhere in your application for your LLM. Just hit this with your query. Maybe it's the effect of President Xi's visit to France. And you get your news context, toss it into GPT 3.5, and now your LLM is news aware. Gain some more control over it, control stuff. Check it out. We're really prioritizing low latency for Ask News. So we really want it to sit in a tight part of your stack where you don't have a lot of time. That's it, and I really appreciate your attention, and I apologize if I went over, but thanks.
Oh, thank you. It was perfect. Thank you. Do I have any questions from people? Yes, one here.
Something like this. I guess you mentioned what you're using to train, where you're getting your data sources for, and are they balanced? You know, when you look at Russia, it has some news sources that are very pro-Russia, and there's less than there used to be, but that are not. And in reality, both provide a point of view that maybe should be considered. So do you show your own sources, and do you consider kind of all sides of the argument in those sources?
Yeah, we have a transparency dashboard, thanks to Ellen again, which shows all the distribution of the sources, where they come from. I probably should have tossed it up. It's at asknews.app if you want to check it out. Now, prioritizing different types of sources is a really good question. What do we do with RT? Right? Everybody knows what RT is about. And interestingly, that crops up in the contradictions, right? So once you start asking for contradictions, you start seeing, well, RT is reporting it this way, and source in Germany is reporting it this way. Do with that information what you will. At no point are we ever interested in reporting a fact, right? We're just reporting alignment and contradictions. So at the moment, that's how we're handling it. But it's a research topic, very interesting, and we'll be diving deep into this.
Thank you. Well, one here.
Thank you. One question regarding licensing. I mean, we've heard a lot about licensing news articles for AI. How are you dealing with that?
So everything that we use is open web. So it's open web scraped, and all of the information that we provide is synthetic data. So what we've done, we've essentially synthetically created the document through an LLM, which is translated a lot of the time, right? So you're getting an English document that was open scraped German or something. And so, yeah, we don't touch paywalls. We don't go behind paywalls, don't give those, but it's probably going to be something we have to think about moving forward with a lot of pieces. We are releasing a data set for Gleiner News, which is all synthetic data off of open web that we've translated. There's still some questions around it. Everything we can find is that this is okay, especially when you do a translation, and but for sure, it's really an important piece of the puzzle.
Thank you. Any other questions? One here.
Kind of related to the first question, when you talk about alignment, are you just talking about if things seem to agree, or are you exploring questions of like editorial slant? Like, have they used the first person or the third person to describe, like, someone was murdered by X, or, someone was killed, which has been a big topic and used recently. Like, how do you think about these sort of editorial slants as part of the alignment question?
We aren't defining any editorial slants or a priori making any decisions like this. When we say alignment, we just say, hey, these sources are all saying this, or these sources are saying different things. So, but it's a topic we're very interested in. So if we can get a data scientist on it, I'm sure there's tons to explore.
Thank you so much for the presentation. I have a question regarding like unsupervised methods that you use. I can imagine, for example, that you have news, then you try to cluster them, which is also like an unsupervised task. Then, of course, you need to describe each cluster to understand what is there, to summarize it somehow. And then you also mentioned that you do it for different time points, and then you track kind of changes. So try and identify that this cluster is still the same, kind of it moves across time. And I can imagine there should be a lot of parameters that you need to define to make it work. So to stabilize this unsupervised, group of methods. So how do you find this or set those parameters to make sure that it works on scale? Because I could imagine that I think it could be tricky to do. Yeah, thank you.
Yeah, I mean, you're just describing a lot of the troubles that we go through. A lot of trial and error, to be completely frank. One interesting piece is, hey, we doubled our scraping overnight, and then we realized, oh, the HDB scan parameters need to change because you define a minimum cluster size, and all of a sudden you've densified your cluster by 2, and now if you want to maintain a certain total number of articles. So trial and error, hate to say it out loud, but it's true. Happy to find a better answer though.
Any other questions? One here. All right. It's a very big space.
Hi, I have one question, which is basically, I read something on Twitter yesterday where Twitter has their own LLM model. I believe it's called Grok. So Apple had an event today, but Twitter's model, the Grok, started speculating yesterday, which was actually correct to some extent because it was based on last year's Apple event. But in that case, how does this handle that? And this could also be tied to your example of the Madonna's concert, where the news was sort of speculating 1.5 million people would be attending. And in that case, how do you handle that?
Well, we give it up to the minute information. So as news, we're filtering. If you're going to ask for news context, you can decide how much news you want. So if you want last year's news, then you could grab it. If you want the last hour, you grab 1 hour, and then you would control to make sure that, hey, I'm only talking about the last hour of news, but that would be the approach.
Cool. Thank you very much.
Thank you.
Thank you. We're going to take about 5 minutes break if you want to grab a drink or something, and then we'll go for the last talk, all right? Thank you. It's time for our last talk. And then after this talk, I promise you can have a lot of discussions. You can ask questions to the speaker. And yes. So last talk is from Delivery Hero, actually. And it's titled, I See Eyes in My Soup. You can see this amazing image. So we have 2 speakers. We have Nikolay, which worked for 7 years at Yandex, sorry. He's then moved to Germany and worked as a computer vision specialist in a fashion-related startup. And for the last 6 months, he's been working at Delivery Hero as a data scientist in the AI menu content team. In his spare time, he collaborates with his partner in contemporary arts with the help of AI, and he's also interested in poetry, algorithm, microtonal music, and graph theory conjectures. That's one speaker. Then we have another speaker, which is Iaroslav. He's a data scientist at Delivery Hero. He laid out the foundation for a number of projects within the food science domain, and now he develops solutions within the area of generative AI. previously, he founded an edtech startup, a crowdfunding platform for sentiment analysis. He also led a group of engineers at CDEK, I'm sorry if I pronounced it wrong, one of the largest logistic companies in Russia. Thank you all, and you may go.
Thank you. Hello, everyone. So before we actually start, please raise your hand if you find this slide a little bit too clickbaiting. Like, yeah, some people like this. So actually, the marketing team has decided to help us with this. And this is not a real image that was generated by our system. I just want to disclose this. And yeah, so my name is Iaroslav. This is my colleague Nikolay. Both of us are data scientists at Delivery Hero. And today we're going to talk about how we implemented this safety system for our AI-generated image solution at Delivery Hero. And I wanted to start with some brief recap of the basic equations to make sure that everyone's on the same page before we go deeper. But the PR department asked me not to do this. That's why I'm going to tell you about our company, because this is much more interesting and important for us. So Delivery Hero has a mission to deliver anything and anywhere. We deliver prepared meals, groceries, flowers, coffee, and medicine. And we have a huge family of brands that operate across more than 70 countries across the globe. And we have exposure to 4 continents. And actually, I can understand why we didn't go to Australia, because they have spiders and alligators. But seriously, what's wrong with Antarctica? There's no competition there, actually. So probably I should talk to someone from the strategy. Yeah, our today's talk will be divided into 2 parts. The first part is about food image generation, where I will be talking about who we are, what we are doing, why we are doing this, and how we are doing. And the second part is going to be from Nikolay about the safety system and how it is implemented within our scalable solution. So let's go for the first part. And this is our AI menu content squad. The mission of the team is to build scalable solutions for creating and improving visual and textual content of the product offerings to deliver the best experience for both our customers and our vendors. And this is one of the most talented, advanced, and professional group of people in this area. And I'm telling this because they asked me to tell this. So what are the prerequisites for having an image generation solution hosted within the Delivery Hero? The business hypothesis was that the quality of the menu content increases conversion, which means by increasing conversion, we increase the sales and the amount of revenue that we get, which is important for our business. And based on the analysis that we have conducted, we actually have figured out that actually the most share of the products that were sold, they have an image, surprise, and most of them also have description, and there are regions with really, really high percentage of missing images. So by targeting these regions, we could probably increase the revenue of the company, and that would be something that we would like to achieve. And after conducting an A/B test, we have confirmed that this hypothesis is valid. That's why we have decided to move forward with implementing such a solution for generating images. And when the product came to us, they told me that the solution is pretty simple. And you don't need to overcomplicate this. You just need to take data, generate images with AI, and share the data with our stakeholders. There are only 3 steps. What can go wrong? Yes, and you have only a week to build this. So after discussion, we have brainstormed with the team how and what we can build. And we've came up with 2 solutions that we can implement. The first one is fast and scalable, The second one is complex and elegant. And since we had only a week to implement all of this, we didn't have time to discuss which one should we work on, so we've built both. This is the first one, which is called the dynamic background, and why it is dynamic. So actually, how does it work generally? We have a textual prompt. This is text to image generation, and we have some product name and meta information like dish-related attributes, keywords, and stuff like this that we aggregate and extract from the metadata from our data hub. And also we have a background here. You can see in the green brackets, this is an additional part of the prompt that is used to, during the generation process, to condition images also on the background, such that we can have a variety of dishes on different backgrounds. Why is this important? Because different brands have different requirements for the backgrounds. That's why we need to have an opportunity to suggest them different options. The second solution, which is complex and elegant, was to actually use the existing backgrounds from the vendors and like tailor inside them, such that the whole output menu looks organic. And here we have several steps. The first step is to select the appropriate image. And here's the first limitation that we face, that we cannot generate images for the vendors that they have not suitable backgrounds. The second step here is to detect the object. We're using grounding dyno for this. The third step is by far the most simple one. We just mask this. And the last step is in painting. So in the end, we have pretty elegant solution. And the technical details for the MVP solution, we've decided to keep to GCP and keep frugal. Our generation pipeline is based on Vertex AI. What is Vertex AI? This is actually a thing that is built on top of Kubeflow, which is built on top of Kubernetes, which is built on top of Docker. So we have this layer of abstraction, which allows us to build solutions fast. We have also some kind of a backend, and the major part of the system here is the dynamic background generation that I mentioned, and the tailored background generation, which has a little bit more components. That's how the whole pipeline looks like. I'm not sure if you can see it properly, but this small part is the dynamic background, and all of this, and also something hidden inside, this is the tailored background generation. And for the MVP, the requirement was to have the opportunity to select the images. So the output were the Google Forms that we have submitted to the content teams, such that they could go through the generated images and choose the most appropriate ones based on their expertise. And after the MVP, we have decided that it was actually fine, and the solution, we have confirmed the business hypothesis, but the solution wasn't really stable, and there were questions regarding the scalability. So we have decided to move forward and build a scalable, cost-effective solution, and that was the second part of our journey. The stack of technologies grew because we had to migrate to the cross-cloud architecture, as well as the number of services that we use. And the reason why we have migrated to cross-cloud, because of budget optimization, and because different vendors provide different technologies that we use. But generally, it was interesting and complex, as everything that we do. How the cross-cloud looks like this. So we have still the image generation part here with the backend served on the GCP, and the inference cluster is located on AWS with a family of models that are served there on the specific hardware that we have chosen for each of them all, and they communicate with each other via the messaging, and all of this helped to our talented group of engineers. Thank you very much. They're here. Yes, all of this make it work for the final solution that we have now in production, which is the application for the vendors that we have, which allows vendors to go there directly and choose the most appropriate images as they find them for their own menu. And we already have the examples of images that were accepted to front end, and that see our customers and increase revenue for our company. And that would be actually easy to if there weren't buts. The thing is that the image generation models sometimes kind of misunderstand you. So the request was to generate chicken with potato. Well, technically it is correct, but probably not something that we'd like our customers to face. So that's why we had to implement the safety system for generating images. And Nikolay, my colleague, will talk more about this. Please applause.
Thanks. Yeah, thanks, Yaroslav. I probably won't be so funny as Yaroslav, so sorry. But okay, yes. So the problem we are trying to solve is that it's in two parts. One of them is that the current generation of text-to-image models still don't understand the prompts that we are asking them about. And also, we want to suggest several images to the vendors or to the content teams, as you may have seen. And we would like to, for example, to rank the images and score them and show them like from best to the worst. So we've implemented a safety system which will filter out bad images and also rank the images. And here you see the 4 components that we have kind of implemented and identified as the most important ones. So I will talk about the upper 2 components. The first one is about detecting objects in the images. The second is about whether the food is cropped or not. The third one is about text detection. And the fourth one is about how much information actually is in the image, whether it is sharp or blurry. So the first component is about tagging the image, and it is based on the so-called recognize anything model, which was introduced about 3 months ago or something, the latest RM++. So the idea is that we can recognize 4,500 tags, that this model can do this. And we have identified 10 so-called food tags and the 50 negative tags. Each component that we use produces a score between 0 and 1. And usually 0 means bad image. In this case, it will contain at least one of the bad tags, for example, animals or the eyes or anything else. And the good image should at least contain one food tag and no bad tags. So here you can see that the model produces a long list of tags, but yeah, we just focus on the selection of it. So briefly, how this model is constructed. We start with a data set, with a huge data set of image text pairs, which is also, for example, used to train the clip model. And then this model uses 2 frozen foundational models, one for the tagging, from getting the tags from the text, the other one to get the object detector and the tags from the image. And then we have the usual text encoder, image encoder is in clip, and then the last interesting part is that we want some kind of alignment between the image tags and text tags. So this is what this modality interaction block is about. And what we try to train is this kind of tagging head which goes from the image encoder. And in the inference, we just throw away everything and just take the image tagging part of this model. It was actually the architecture of the text-to-text model, which was introduced a year ago. Then was the recognize anything model, and now it is REM++. Actually, right now it is about two tasks, the image tagging and the alignment between image tag and text. And yeah, it uses a lightweight transformer for the alignment, so it is quite fast and pretty accurate, as we will see. And also it is pre-trained on the huge data set with a small resolution and fine-tuned on a higher quality data set on a bigger resolution. So let's talk about a little bit about the metrics. We've collected a data set of 10,000 images, manually went through it and labeled it. And then here you can see like there are two interesting things here. One of them is false negatives. So we label the image as a monster, so-called or inappropriate image, and the model thinks that everything is okay. The list of tags is okay. And here actually there's 7 out of 10,000 images. You can see here, and the other number is the false positives, it's 8%, so 800 images. And it can seem to be quite big, but what it means is that we originally labeled this as a food image, but the model predicts this as a monster. But it's nice to be on the safe side. So here are some examples where the model detects, for example, animals, eyes, faces, and stuff like that. And so we will also filter out these images as inappropriate. And I will talk about the second component, which is about image centering. So it is based on the grounding Dyna model, which is also an open source. You can find it on GitHub. The logic is also we will give 0 score to the image if we haven't detected anything. Like we try to detect the plate. 0.5 is if the image is cropped, and the 1 if the image is in the center. And yeah, the architecture is very convoluted, so I won't display it here. But basically, the input here is actually an image and some kind of text. And that's why, and the text is very arbitrary, and that's why it is called grounding. And afterwards, you have image encoder, text encoder, you have self-attentions for each of the encoders, you have cross-attentions between these encoders. Then you need to actually select, in the paper they write that they select 900 pairs of detected objects from the text and detected bounding boxes of various objects in the image. And then in the end, you have some of the two losses. One of them is contrastive loss, which is used in CLIP. And the other one is so-called getter loss to score these bounding boxes, whether they are good or not. So yeah, and finally, we combine all these components together with some kind of decision-based weighted scoring logic. This is what we get in the end. So here's a random selection of 9 images. And after applying a threshold, we will filter out around 1/3 of the images. And yeah, the output looks much nicer. So we won't scare our vendors and the content teams. So yeah, that's the end of my part. But before we go to the questions, we have a small addition. So we like to play this game, and we'll test it now again. So yeah, the idea is to try to guess which of the images are AI generated. So let's try to vote. So please pull up your hand if you think if the first image is AI generated. Okay, what about the second image? Okay, nice. So what about the third image? What do you think? Okay, cool. So here are the results. Okay, who guessed it correctly? Yes, so you already know the answers. Okay. Okay, here's the same. What about the first image? Please raise your hands. Okay, what about the second image? What about the third image? Oh, wow, okay. So here are the results. Yeah, who guessed it correctly?
Sonia, you know the answers.
Yeah, okay, you can detect people from our team, I guess. And the third one. What about the first image? Okay, nice. What about the second image? Cool. What about the third image? Okay, nice. And the answers are here. Yeah, okay. And now the questions.
Thank you very much. Thank you. Do we have questions? One here. Do you work here? Do you have any other questions?
Hello. It was really an amazing presentation. Okay, using generated AI images, really good for the organization, good. But how does Delivery Hero ensure that the dishes that the users see on their platform is what they are actually receiving? Like, do you take any steps like, okay, fine, the user has seen, okay, he's receiving that.
Yes.
Yeah, thanks a lot. That's an amazing question. And the major goal generally of Delivery Hero is to ensure that our customers get the best possible experience. So as we know that, first of all, for some of the products, some of the vendors already use stock images and we provide such a service. So in this case, the stock images, they are probably used for pretty standard products like burgers and pizzas. And the amount of difference, the data there between the expected and what was brought is limited, how to say. The second step is we are also targeting to increase the revenue. And here we are driven by our the metrics that we want to get. And it is better based on what we have talked to the content teams, that if a customer has at least a reference image, and moreover, we mentioned that the image is the reference image and the real product may be different. But this is already increasing the user experience. And also we are here to make the images as close as it is possible to the real products. And we hope to get there by some time in the future. Thanks a lot for the question. That was an amazing question.
I know you answered that question, but I want to dig into a little bit more deeper. Yes, you have stock images. Yes, it's a representative images. But I want you to think through my mind for a minute. Imagine that the images and what the customer received does not match. And I'm sure your metrics are showing up for the short-term future. But from a long-term perspective, when these images don't match, that would drive down customer satisfaction, and that might affect you on a longer time scale, right? So here's my question. What are you measuring to make sure that your long-term customer satisfaction remains where you want to be?
Oh, that's a great question. Do we have Alexei here, who's our product analyst? Or he's on vacation?
Call him.
Oh, sorry. Do you have like any? we definitely, what I can say is we have metrics, and Alexei was the person who has the knowledge over all of them. Unfortunately, we have here Vladimir, our engineering manager, who can address this question.
Okay, I think we missed one important item in the content creation chain. It's the vendors themselves and the content teams. So we are not really exposing the generated images directly to the customers without any human moderation at this point. So they do come through the human moderation step. So these forms that you saw in one of the slides, they are actually shown to the content managers who we hope know how the dishes actually should look like. Or we show them to the vendors who I hope know what they cook actually looks like. So this is, I think, our main guardrail at this point. But in terms, going back to your questions about how do we measure that we are providing content in a sustainable way, then of course, analytics. So we need to track over a long enough period of time how these products with Gen AI images perform. And not just on a short term, like you said, we just generated some images and people are excited to receive, but then they receive something else. Then we will see that in the churn metrics over several weeks' time. So we need to monitor it for a while. And I think pretty basic analytic events are going to be substantial for that. Hope that addresses the question.
Do we have any other questions? You already asked one, so I'm going to just give it to someone else. And then you have the next one.
Fine. Hey, hi. Thanks a lot for the presentation. That's quite interesting and everything. My question is going to be slightly from a different side, let's say, it's a different perspective, because eventually Delivery Hero is a business, right? And of course, the images that either you're using the stock ones or the ones that you generate, they're meant as well to drive more customers, right? Whenever you open the application, you're like, wow, that looks amazing. I want to have this. But somehow I missed this specific parameter into your algorithms you're using right now to pick the correct images, right? Because it is one thing, of course, to create a nice framed image, and another thing, of course, to be safe into what you're using. But definitely so, you might think that an image framed correctly is fine, but for a customer might say, yeah, the image that is in the corner and cropped, it is even better. So how do you deal with this kind of data? Because I haven't seen it being mentioned.
Yeah. So currently, yeah, thanks for the question. The current logic that we have is that yeah, we just take the scores, we aggregate them in some kind of way, and then we rank them according to the score, let's say. So for example, we take all of the 4 scores, average them out. We again get the score from 0 to 1, and then we, for example, we have a GoDroid application, and then we show to the vendors the images from what, let's say, our model thinks the best one to the worst one. And then the vendor is free to choose any one of, let's say, 7 to 10 images of what the vendor thinks is the best one. And like currently, we also see that we have a nice variety between the images. So yeah, currently is this what is our approach.
Thank you for presentation. I have a question, but maybe it was partially answered. My question is, when you deploy a model, what metric do you use to understand that your model is actually better? Because you, like, from what I understand in presentation, you have Gen AI problems and you try to solve it with more Gen AI. So maybe some issues you couldn't catch, right, with your metrics. What's the end metric you use to improve model?
Yeah, thanks a lot for the question. So whenever we talk about Gen AI, and this refers to image generation, both image generation models and text generation models, which is also referred as LLMs nowadays. So the problem is that we can assess the scores by some metrics. For instance, we can measure sharpness, we can measure white balance, color contrast, and so on. We can measure even if an image is cropped or not. The challenge here is to understand if the, in our case, image generation model is correct in terms of semantics. And that's the most challenging part, to understand if the generated image of chicken with potatoes actually matches the prompt. And it actually matches the prompt. The problem is the semantic understanding and the understanding of the context. So it was quite hard to iterate between the epochs of experimentation when we were tuning parameters and configurations of several image generation models. But the solution that we have come up with is actually a benchmarking framework that allows us to automate the process of testing the models, and it works as actually a more complex version of the safety system that we have. So it's outputs the number of scores, aggregates them, and that is used in an automatic A/B test to compare the images that were generated by two different versions of the models to come up with the candidate model that is better according to the A/B test. So this whole framework works in fully automatic way that allows us to iterate fast in terms of model experimentation. However, we also need, and this is the most crucial point, is that we need human in the loop process to make sure that the images that the model generate, they also are compliant with our human expectations to what we expect to see from the images. That's why when we have a strong candidate model that we are ready to move to production, what we do is we also ask our content teams to help us with the evaluation of such a model. And if we have green light from them, the model is deployed to production.
Thank you very much. We had more questions, but I'll let you ask them directly at the end. Thank you very much for the talk.
Thank you.
Yes, please. And that's kind of it, honestly, for the meetup. I'm just gonna share my screen again. And yes, if you wanna have a break, if you wanna do. Okay. Sorry, it was actually still playing. So yes, that's it. That's all the meetup. Thank you for coming. You should already be in the group anyway, but yeah, we'll see you end of June. It's a monthly event. If you're a speaker, if you want to speak at the next meetup, you can contact us directly. You can contact me on LinkedIn. You can reach out everywhere. Thank you very much. Thank you to Delivery Hero again. And yeah, enjoy your evening. Thank you.